So I'm going to go ahead and do a lesson for you to continue on with input and output, and I'll try to make it as clear as possible. So yesterday we talked about inputs and outputs, and remember we said an input was our x coordinate and an output is our y coordinate. Another term that we can use for input is the domain, and another term for the output would be the range. And sorry, my pen's not always writing well. So our input is our domain of a function, and our output is our range of the function. And it kind of helps if you think about it like a function machine. So say I have an x, and I put it into this like function machine or like the vending machine, and then out comes a y. So I have my input, I put it into this machine, and I have an output. And if my machine has an expression, it makes it easy for me to figure out my output. So for instance, if I have an input and I put it into what we call the rule, and say my rule is x plus 3, and it takes me out to an output. So think about it this way. So if I have an x and I plug it into this rule, x plus 3, and I'll get an output of y. So assume that I say that x is 1. If I plug it into this rule and I substitute x in, or 1 in for x, then I would have 1 plus 3, which is 4. So every time I put a 1 in for x, my output, or my y, would be 4. I can choose another number for x. Say I have a 2 for x. If I put a 2 into this rule, I substitute 2 in for x, then 2 plus 3 would equal an output of 5. Maybe my input is -1. So if I have -1 plus 3, my input's -1, it goes into this rule, and then my output would be 2. So inputs, outputs. Your input is your x, your output's your y. Your domain is the same thing as your input, or your x, and your range is another term for the output or for the y. So let me continue. Let's try another one like that. So I could have an input, which is my x, and say my rule is 2x minus 1. Which would give me my y, and I might go ahead and have one more column, which I'm going to call my ordered pairs, my x, y. So if I put in, say, -1 for x, then 2 times -1 minus 1 would give me -3. So that means my ordered pair would be -1, -3. If I substituted in 0 for x, then 2 times 0 minus 1. Well, 2 times 0 would be 0, and 0 minus 1 would be -1. And my ordered pair would be 0, -1. Maybe I want to substitute 1 in for x, and if I do that, 2 times 1 minus 1. 2 times 1 is 2, and 2 minus 1 is 1. And my ordered pair would be 1 and 1. Okay. Input, output, and rule. Input, rule, output, and my ordered pair. Next question is, can I choose any number that I want for x? And the answer is it depends. If I'm just doing a plain old math problem, then I can use any real number for x, and that would be fine. Any number that I choose, positive, negatives, it wouldn't matter. But if I'm doing a real world situation, there could be constraints, which means it may not be possible to use any real number. For example, if my domain is, if my x is equal to money in a vending machine, My pen is just kind of tired, guys. Sorry. So if X represents money in a vending machine, is it possible to have negative money? You can't put negative money in. You either have money to put in or you don't. You can't put zero money in because the same thing, you have to put a positive number in. So in that case, your X's could not be 0 or negative. Negative. So, because that would not make sense. So that's really what I wanted you to get out of today's lesson, just knowing that you have domain, which is the same thing as an X or an input. Your range is the same thing as Y or your output. You can substitute your X's in to a rule, and then every input creates an output, and then you can write it as an ordered pair. You can go ahead and start working on the assignment now for lesson 5.2, and I will see you all tomorrow.